Natural log differentiation. You may recall that the power rule for integration is this here. If we have x to some power dx, we can take the antiderivative of this by adding 1 to the power and then multiplying by the reciprocal of the new power, and then of course remembering to add c. And this rule applies as long as n is not equal to -1. For the simple reason that when you multiply by the reciprocal of the new power, -1 plus 1 is 0, the reciprocal is 1 over 0 or anything over 0, and this creates a divide by 0 situation. That is impossible. So what happens when n equals -1? Well, in order to understand that, we first need to understand this. This is the definition of the natural log function. That is, the natural log of x equals the definite integral from 1 to x of 1 over t dt as long as x is bigger than 0. And this makes sense because when you are looking at the graph of this integrand, 1 over t, the graph of that looks something like this. And there's a second branch over here. So what's happening is when you start at 1, right, is this definite integral starts at 1 and goes to x. Remember, if we're traveling from the left side of an interval to the right side of an interval, say here, that area will give you something positive because we are in fact moving from left to right. When you put x on the other side, maybe right here, this integral still holds. It is still from 1 to x, but now we're going to the left. And anytime you go to the left, you are finding a negative area. So if you think about this in terms of what the actual natural log is, so here is y equals natural log of x. Here's 1. Any y value to the right is a positive value. Any y value to the left is a negative value. So that makes sense if we pick a number greater than 1 to evaluate in this integral. It's going to be a positive area, which is why all these y values are positive. If you pick a number less than 1, since we're moving right to left, this will give you a negative area, which corresponds to these negative y values over here. So this section is called natural log differentiation, and I'm showing you an integral definition for natural log. How does this help us? It helps us in the following manner. If we take the equality from the first page, that is the natural log of x is this integral, and we're talking about the derivative, we can take the derivative of both sides with respect to x. So we want to find the derivative of this and the derivative of that. But this derivative is another form of the second fundamental theorem of calculus. And the second fundamental theorem of calculus states that if we start a definite integral at some constant and go up to x, essentially we can just drop this x right into this function, and we will get that the derivative of the natural log is equal to 1 over x. And you'll find very quickly that with this section, we will basically be doing a mini review of everything that you have learned so far in this course. To explain what I mean, we will be taking the derivative with respect to x of the natural log of u. where u is some function in terms of x. So if we were going to take the derivative of something and we have another function inside of it, this uses the chain rule. So this would be giving us 1 over u per the definition up here. The derivative with respect to x of natural log of x is 1 over x. So whatever's on the inside ends up in the denominator. But then we would have to take the derivative of this function u with respect to x. So that'll look something like this, du dx. But another way to write this portion is to call it u prime. So we can even write this simpler as u prime over u. And before we get into any derivatives involving the natural log of u, I want to review some properties of natural logs. Some properties of the natural log function include what the domain and range are. The domain of the natural log function I mentioned earlier is all positive real numbers or all non-negative real numbers, same thing, from 0 to infinity. The range is all real numbers from negative infinity to infinity. The natural log function is in fact continuous on its domain. It is increasing always on its domain, and it is one-to-one. One-to-one may be something you haven't heard in a while. It means that the inverse of the natural log function, f of x equals e to the x power, is also a function. The last property of the natural log function specifically is that it is concave downward everywhere. Some properties of logs in general are these down here. You've probably seen these before. The natural log of 1 is 0. The natural log of a product of two expressions is the sum of the natural log of each expression. The natural log of the quotient of two expressions is the difference of the natural log of each expression. And if you have the natural log of an expression being raised to an exponent, raised to a power, the power can come out to the front like this. That's why this n is out front now. And while we're here, to get one more property of natural logs for your information is that the natural log of e to any power is just that power. And that is because if you use the power rule down here, like this, the power comes out to the front. That will be looking something like this. That will give you that the natural log of e. But one other thing that you need to know is that the natural log of e is 1. So this will be 1, n times 1 is n. So this is the last property that you need to know for the examples.